Okay guys, in this video we're going to be using what we know about matrix operations and including all operations, that's addition, subtraction, scalar multiplication, as well as matrix multiplication in order to simplify matrix expressions. And so you notice that I write here, it says we can also simplify expressions involving matrix multiplication using the standard order of operations. That's going to be one of the big ideas of this video, is this idea that the standard order of operations applies to real numbers, but this also sort of applies to matrices, even though there is no such thing as matrix division. And we tend to, not a lot of the time, use exponents, but you can. So that would still apply here even. So we're going to do these steps in this order when we do this. One thing that I do want to mention here, though, is that multiplication, okay, excuse me, includes scalar multiplication as well as matrix multiplication. And that is to say that in terms of priority, if you see a scalar multiple like this 2 out in front here, that takes just as much priority as, say, a matrix product like these matrices are being multiplied by each other. So let's go ahead and take a look at just a few examples that I've got listed here to show you kind of the steps you would take to simplify expressions such as these using your order of operations. So looking at letter A, it says, let's take this matrix here, this 2 by 2, and let's add it to this 2 by 2 that we're multiplying by this 2 by 2. Now, first things first, in terms of order of operations, I don't see any parentheses, I don't see any exponents, but I certainly do see multiplication right here. So in terms of what we must do first, we have to do this first. Must do first because of our order of operations. And so what I'm going to do is I'm just going to rewrite everything down here, but what we are going to end up with, okay, is a new matrix when we multiply these two right here. So we have 3, -2, 5, 1. Was our original matrix, and we're adding this to the product we get when we multiply these two matrices. Now, when I multiply these, first of all, I can do it because my inner dimensions match, but second of all, I know the size of the answer I'm going to get. So I'm going to get this 2 by 2 matrix right here that I'm going to leave myself some room on, as a matter of fact, and I'm going to put in my 2 rows and my 2 columns here with blank entries. So now we just have to multiply these two matrices. Now, looking at this as I got to do first row, first column, we'll take our first row times our first column here. So starting at the beginning of the row, beginning of the column, we say 9 times 1. 9 plus, now move over in the row, move down the column, -4 times +2 is -8, okay? And so now this would be in our first row, second column, so we'll take our first row times our second column. Starting at the beginning of the row, beginning of the column, we say 9 times -3 is -27. Plus, now we'll move over in the row, we'll move down the column, we say -4 times -2 is a +8. Okay, so now moving on, we say second row, first column, we'll take our second row times our first column here, so 6 times 1 is 6. Plus, now move over and move down. We say 3 times 2 is 6. And then second row, second column, we have second row, second column. We have 6 times -3 is -18. Plus, now move over and move down. We have 3 times -2 is -6. So we're going to rewrite all of this again. And I understand that rewriting is not a very appealing thing to do, especially when you have to do it a lot. But it's really going to help you here. So we're going to say, well, our cleaned up answer is 9 plus -8 here. That's a 1. 6 plus 6 here. That's a 12. -27 plus a +8, that'd be a -19 as I count it here. And then we say -18 and the -6 here, that would give us a -24. So here's our product matrix right here. Now we can go ahead and say, well, what would be next in our order of operations? Well, we would add these. And we certainly can add these because they have the same order. We can only add matrices if they have the same order. So the neat thing about matrix addition, remember, is that we just do it component-wise. So we're going to say 3 plus 1 now, that's our 4. We say -2. Plus -19, that's -21. 5 plus 12 here is 17. And then lastly, 1 plus -24 is a -23. So this would be our simplified matrix that we would get from this expression up here. So you can see the importance of using the order of operations. Let's take a look then at a different example in which I put a few more things involved in here. So starting with the fact that what you see here is that this situation has parentheses. And so looking at what we're doing, we have a matrix times, well, we're going to get a matrix in here, but we would say that inside here we have parentheses. I'd have to do these things first. So in terms of what I would do first inside the parentheses, I would start by going ahead and doing my multiplication, since I have that to do in here. And I mean scalar multiplication. So we're going to rewrite this, and what we have out in front is 1, 2, -3, -2, okay? And then we're taking that times in parentheses. Now I haven't done anything with this matrix here. It's this 2 by 3 matrix, 1, 3, 7, -3, -5, -3, and 2. And then what we're going to do is we're going to add that to 2 times all of these. So we're going to go ahead and distribute our scalar here. We say 2, 0, -6, okay? and -2, -1, and 4. Now these are all still in parentheses, meaning that before we do this multiplication that we see right here, we're going to have to add these two matrices first. So the neat thing is 2 rows, 3 columns, plus 2 rows, 3 columns, we get a new 2 row, 3 column matrix since we add component-wise. So I'm just going to rewrite my matrix out in front here. And we're going to say, well, in parentheses, now what I have is this new 2 by 3, okay, 2 row, 3 column. But in the first row, first column entry, I have 1 plus 2, which is 3. I have 3 plus 0, which is 3. I have 7 plus -6, which is 1. Now going down here, we say -5 plus -2 is -7. -3 plus -1 is -4. This is a 1 here. Okay, and then 2 plus 4 is 6. So now that I've got these written out and I have multiplication here, we look at this as a multiplication situation. I have a 2 by 2 times a 2 by 3, which means first of all, we can totally do it, and second of all, we're going to get a 2 by 3 for an answer. So what I'm going to do is on my final expression here, I'm going to write something that has 2 rows and 3 columns, and because it has so many columns, I'm going to stretch it out a little bit here. So we're going to populate our empty 2 by 3. We say, here's our product matrix. What we're going to do is just chase after an entry at a time. And so in this case, first row, first column, we'll go first row times our first column, starting with 1 times 3, which is 3, plus now move over and move down, 2 times -7 is -14. Now we'll go first row, second column, so first row times the second column, we have 1 times 3, plus move over, move down, 2 times -4 is -8. Then we have first row, third column, so we'll go first row times our third column here, we have 1 times 1, which is 1, plus now move over, move down, we say 2 times 6 is 12. So that takes care of our first row there. Let's go now second row times our first column to get our second row, first column entry. So we get second row times our first column, we get -3 times 3 is -9, plus now move over, move down, -2 times -7 is 14. Now if we were to move now second row, second column, we have -3 times +3 is -9, plus now we'll move over and we'll move down, we say -2 times -4 is 8. And then we'll say second row, third column, we have second row times our third column, -3 times +1 is -3, plus -2 times 6 is -12. So we'll just clean this up now that we've got our product taken care of here. 3 plus a -14 is a -11. Okay, -9 plus a 14 is a 5. 3 plus a -8 is a -5. -9 plus a +8 is a -1. And then this last column here, we have 1 plus 12 is 13, and we say -3 plus -12 is -15. So this would be our final simplified form of this matrix here.